Got a speed, distance, time question here. The first thing, the hardest thing actually, is to get a good diagram down for what is going on, and then, it's all about implementing equations carefully. So we've got Exeter and we've got London, and they are a distance 175 miles apart. Just going to write 175, everything is in miles and in hours for the time being. I know ultimately we have to get this time in hours and minutes. So then I've got Sam leaving Exeter and going 25 miles per hour. And at a later point, 3 hours later, in fact, Morgan is going from London to Exeter 35 miles per hour. Okay, and they're going to meet somewhere like, I don't know, here, because Morgan leaves later, but Sam's going slower. It doesn't really matter. It's just a point. Okay, I'm going to talk about two different ways to do this question now. Actually, the solutions show this really nice way. I didn't think to do it this way, but it is to basically try and set it so we're looking at what is happening at 1 o'clock. So we look at the first 3 hours of the journey, actually, from 10 until 1 o'clock. And during that time, we're going to have Sam go 25 miles per hour for 3 hours. So we're going to go 75 miles in total. And then we can kind of start the clocks at the same time. So we can almost forget about it. We can change the problem so that now we've got them starting um, Sam's starting from here and Morgan is starting from here. And now the total distance is going to be 100. So let's then say that Sam is going to move some amount, let's call it x, and then Morgan is going to move the rest. It's going to be 100 minus x. Okay, then we can construct some equations. So Sam is going 20, so speed is distance over time. So 25 is equal to x divided by time. Okay, not a lot we can do with that because I don't know either of those two things, but for Morgan, I've got a similar equation. 35 is going to be 100 minus x divided by the same time. Just kind of want to recap what I've done so far because I hope this is making sense. I've set up my diagram, I've put in 175 miles, and then I've just considered the first 3 hours from 10 until 1 o'clock. Sam is moving 25 miles per hour for 3 hours, so goes 75 miles. So basically, at that 1 o'clock time, they're 100 miles apart, and you can almost just like forget all of this and just turn the problem into it being 100 miles apart, and Sam's going 25 miles per hour, Morgan's going 35 miles per hour. They're going to meet somewhere in the middle. So let's just say that Sam moves X miles and Morgan then moves 100 minus X, the remaining amount. Set up these two equations. So speed is distance over time, 25 is X over T. Similar over here, we've got two equations, two unknowns. This is good. So I can write down 25T is equal to X. And over here, I can write 35T is equal to 100 minus X. Now we actually want to know what T is. So I'm going to replace this X here by 25T because that's what it is equal to. This is a substitution. You can combine them in other ways using simultaneous equations, but I'm going to do it using the substitution. So now I can actually, I've got 35T is 100 minus 25T. That's going to mean 60T is equal to 100. And therefore 6T is equal to 10. So T is going to be 10 over 6, which is 5 over 3, which is 1 2/3 hours. Okay, the final answer has the time in hours and minutes, so I'm going to change it. 1/3 of an hour is just 60 divided by 3, it's 20 minutes. So 2/3 of an hour is 40 minutes. So it's 1 hour, 40 minutes. Now remember, we started the clock at 1 o'clock here. Okay, after Sam had moved for 3 hours, that was the start of our problem. So I've got 1 o'clock and I'm adding 1 hour and 40 minutes. Therefore, it's going to be 2 o'clock plus 40 minutes. It's going to be 2:40. That is our answer. Right, I'm not done. I'm going to show you a second way to do this question. This is actually how I did it. On reflection, I think I actually prefer my way because you don't have to do this like extra little bit. I don't know. You can decide ultimately. So the way I did it is I set out in exactly the same way. So I've got X to London. We've got Sam here getting 25. We've got Morgan here going 35 miles per hour. And the whole amount is 175. So I didn't consider the first 3 hours. I just kind of dealt with the clocks in a slightly different way, which I'll explain in a minute. Then I said that Sam is moving X, and then Morgan is going to be moving 175 minus X. Okay, so the setup now for Sam is very similar. Speed is equal to distance divided by time. Right, it's just that the one for Morgan is slightly different because now they're going 175 minus x instead of 100 minus x, but they're not going it in the same time because they're actually taking, because they're starting from 1 o'clock, they're actually going to have taken 3 hours less essentially to go this distance. So then they will have got, when they meet, they would have got been moving for t minus 3 hours. Okay, that makes this method slightly more complicated because you have to realize it, but it avoids you having to do it in 2 steps. Um, so the process then is very similar. I just want to check you're happy with that. So I've set out in the same kind of way. It's just now I've not looked at the first 3 hours. I've just said, right, Sam's moving for longer. Let's call that time t. So the time we get is that we're then going to have to add on to 1 o'clock. Okay. Morgan sets off later, but when they meet, they're meeting at a certain point. Morgan would have been traveling for t minus 3 hours. We've got these two equations. We can again just rearrange them. So 25t is equal to x, and over here I've got 35t minus 3 equals 175 minus x. Now I'm again just going to replace that by 25t. Okay, it's a good method in this case, substitution. So 35t minus 105 is equal to 175 minus 25t. That means 60t is going to equal 280. Yes, I get a slightly different equation this time because I'm finding a different time. It's the time that it's taken Sam to move basically the full time. So t is 28. That means, sorry, 6t is 28. So t is equal to 28 over 6, which is 14 over 3. 3's into 14 go 4, remainder 2, so 4 and 2/3. Okay, so instead of it being 1 and 2/3, it's 4 and 2/3, so it's 4 hours and 40 minutes. So I now add that on to Sam's starting time of 10 o'clock, and we again get this 240. Okay, hope you're happy with that. There's lots of questions on maths challenges, especially later on in intermediate maths challenges, that as long as you get a good diagram down and you use speed, distance, time, you can make a good attempt at. So please, spend some time on this topic. Sometimes there's quicker ways, actually, and you'll see that as you practice more questions, but this is quite a tried and tested method. So well done. I hope you're happy with it.